Good day. Today we will be presenting about integrated multi-sensor smart wearable device for healthcare monitoring. With the rising cases of diabetes over the years worldwide, monitoring devices have become highly necessary for glucose management. Current glucose sensor has bulky structure and complex fabrication, and often involve painful procedures for costly devices, prompting the need for a more accessible and practical solution. Recognizing the limitations of existing methods, we have developed a compelling alternative adapting printing technology for minimally invasive approach. The final prototype consists of disposable glucose sensor integrated with hollow microneedle platform and reusable interface circuit with temperature sensor and heart rate sensor. The integrated multi-sensors wearable device composed of glucose sensor connected through FPC connector, generating microampere range amperometric glucose response to transimpedance amplifier for signal booster. Microcontroller unit processing the sensor signal into readable data and handles all the sensor communication with Bluetooth connectivity. Heart rate sensor to measure heartbeat. Temperature sensor to measure body temperature. These electronics are incorporated on a flexible circuit board in the form of wearable to conforms to the body surface. For preparation, the glucose sensor along with reservoir pad is mounted into hollow microneedle platform, connected to interface circuit, and will be attached to the skin by an adhesive patch. With its flexible design, the device contours to the body's movements, allowing for comfortable wear throughout the day. Users can confidently wear our device knowing that it will stay securely attached to the skin, providing accurate readings without the risk of falling off. Temperature testing using wearable device compared to a commercial digital thermometer. A heart rate sensor is compared with the commercial oximeter. The reading sent to the smartphone correlated with the reading displayed by the digital thermometer and oximeter. Both oximeter and wearable device recorded pulse rate of 93 beats per minute. Digital thermometer measures body temperature as 36.3 degrees Celsius, while wearable device obtained 36.46 degrees Celsius. An artificial skin model is prepared from agar gel to imitate body skin, where the glucose sensor is actuated by finger pressing. Once hollow microneedle array penetrate into the skin model, analyte is extracted through the bore microchannel. The reservoir pad served as absorbent to collect analyte onto sensing area of glucose sensor. The glucose sensor can be tested in the typical range of body glucose from 1 to 10 millimoles per liter. The device is firstly connected to smartphone via Bluetooth, where the device is ready for glucose measurement. The glucose reading is activated by finger pressing. The LED light changes indicating the fluid sample has reached the sensing area. The sensor reading will start after 60 seconds. The glucose readings are collected for 30 seconds and its average is reported. Glucose measurement using wearable device where the reading sent to the smartphone. The actual glucose concentration prepared is 5 millimoles per liter. The final correlated glucose reading by the wearable device is 4.7 millimoles per liter, while glucose meter is 4.8 millimoles per liter. Overall, the current design of glucose sensor with HMN array based on facile printing technology is moderately successful in demonstrating fluid extraction and feasible for on-sensing device activated by finger pressing to detect glucose level. The integration of multiple sensors on a flexible circuit board has enabled the detection of glucose, body temperature and heart rate in real-time monitoring to smartphone. At the end, the fully integrated multi-sensor smart wearable device is proposed as viable solution for the future possible development of low-cost healthcare self-monitoring application.